seen in the field for the past 70 years. We're going to start off with this detail. It's a masonry facade support detail. Consists of a ledge angle, and this ledge angle is actually welded on, field welded onto the steel bent plate pour stop. The limitations associated with this type of detail are field welding. This causes a high degree of high labor, cost, and time associated with running along and field welding along that edge of pour stop. Now there's an alternate detail. Sometimes they have some tabs on here and it spans a little bit farther, but ultimately it does consist of a field weld to that bent plate pour stop. Another detail that we might see associated with masonry facade support is this detail where it's lowered down a little bit and it's framed off of a steel plate, framed off of a steel beam. The limitations associated with this are most of the time it's field welded. So you still have the field welding. Every once in a while you might see a detail that has bolting, but this is very difficult because there's limited access onto the inside of this bent plate that is framing this out. Another limitation also with this type of detail is that it usually requires a lateral brace back into the structure because we have eccentric dead loads that it's supporting out here at the edge to pick up the weight of the masonry facade. Moving on to a different type of a facade connection is precast concrete. And so in this detail, what we would typically see is a wind load tie up here in a masonry concrete that is attached onto an angle that has an embed into the top of the slab. We see that we still have this same steel bent plate pour stop, but it's not being utilized in any way. There's no connections off of that. In fact, they're having to avoid this connection at all costs by going deep into the slab to be able to transition the loads out of the slab and into reinforcing. So you kind of see that there's some extra reinforcing associated with this to develop the loads from the wind that gets into this embed. And ultimately, there's an eccentricity that's associated with this type of connection all the way from the wind load that is applied all the way down to where we want to get the loads into the steel frame structure. One of the additional limitations that is associated with this kind of connection system that is embedded is there's a setback of real estate to the interior. You can kind of see this, that the studs have been set back a ways, and so you lose that real estate. And the next type of facade connection that we see is a lightweight cold-formed steel facade, maybe with some steel panels on the outside or aluminum composite panels. And so this would typically be connected with a typical bent plate connector, and many times this is welded onto that same steel bent plate pour stop. There is an eccentricity that's associated with that weld, and sometimes also we see that in these little special connections, every once in a while they'll fasten it with some pin type fasteners that they explode into the bent plate pour stop. But problems that are associated with this is longevity. We're not really sure as structural engineers about the longevity and the cyclical wind loads associated with the pin type fastener. There's a lot of tests and data out there, but that is usually for when the pin protrudes through a steel member or a steel piece that it's attached onto. In this case, there's no way that a pin can penetrate through that. We have concrete in the back of it. So there's some question about the longevity associated with that, and there's limitations associated with field welding as well if they're trying to field weld that. Another type of facade connection that we see to steel structures is the standard curtain wall glazing system, and usually it looks something like this. Every once in a while we see this detail where it's attached directly onto a steel beam structure. And so we have dead load and we have wind load that's associated with that being transferred back into the steel beam directly. So they avoid altogether that steel bent plate pour stop up there. And the limitation associated with this type of connection system is there's a lot of field welding still associated with welding back to that steel beam. So there's high labor and cost and time associated with it. More often we see this type of connection for a curtain wall where it's welded directly onto the steel bent plate pour stop. And so this still involves some eccentricity to the load that is bending that steel bent plate pour stop. Limitations associated with this type of connection are a high degree of field welding associated with getting that connection onto the outside of the bent plate pour stop. That causes high labor cost and time to enclose the building. An additional type of facade connection that is traditional is where we see every once in a while we'll see this. It's more rare. I'd say it's probably one time out of every 60 jobs that we see something like this, maybe even less than that. But we'll see a light gauge or a regular 1/4 inch bent plate pour stop where they have to cut out a part of it to create a cast in place channel anchor associated with it. In this picture that we see over to the left hand side, this is actually a top of slab type system that's bent and put into the slab. And so you can kind of see this bent frame out here. It has a lot of welds associated with that onto the steel bent plate that we see in the background. A lot of reinforcing associated with it to develop the loads back into the concrete. So limitations are it's rare, it's got a lot of cutting, a lot of field welding associated with it. It's a very costly type of a anchor system associated with this facade connection. So we kind of see the same thing, you know, even in some of these old details from the 1970s. This is an old detail. And we see the curtain wall on the outside. We see that same bent plate pour stop that is at the edge, but in this case we have an underneath the slab type connection, but this still has a lot of field welding associated with it. This just shows that these types of connections associated with a bent plate pour stop go back a long time in history. Here's another one which shows a precast system attached onto a building. We see that same steel bent plate pour stop and a lot of field welding associated with the anchor system onto that steel bent plate pour stop. We see some embed connections to try to transfer the load out and away from that steel bent plate pour stop.